Welcome to Ehela's tuition.
Joules law. Joules law states that heat is directly proportional to square of the current and heat is directly proportional to resistance. Heat is directly proportional to time in second, where H is the heat energy in joules, I current in ampere, R resistance, ohm, T time in second. This is the Joules law. Heat is directly proportional to square of the current and the resistance and the time. From the given table, the first question, resistance of the conductor R changes to 2R and the intensity of current I will be I ampere and the time for which current flows T will be T seconds. What is the heat generated in I square RT? We know that Joules law, H is equal to I square RT. Here I, there is no change in the value of I. Then I square, then the value of resistance R changes to 2R. Then we write 2R into T. There is no change T. Then that is equal to I square into 2 into R into T. Then we can shift this 2 in front. Then 2 into I square into R T. That is equal to 2 I square RT. Then heat generated will be 2 I square RT. Change in heat is twice. Our second question, resistance of the conductor R will be R. Intensity of the current I changes to 2I and time for which current flows T is T second again. We want to find out the heat generated. Heat generated equation Joules law, H is equal to I square R T. Here the value of I changes to 2I. Then we write 2I in the place of I. Then 2I square into R. No change in the value of R into T. There is no change in the value of T. That is equal to 2I square. 2 square 4 I square into R into T. That is equal to 4H. Then the heat generated is 4I square RT and the change in heat is 4 times. Table. Third question is resistance of the conductor R changes to R by 2 and the intensity of the current I changes to I and the time for which current flows is in T second. We want to find out the heat generated. Heat generated equation H is equal to I square R T. Then there is no change in the value of I. Then we write I square into the value of R changes to R by 2. Write R by 2 into time. T changes to, there is no change in the value of T. Then write T. That is equal to I square into R by 2 into T. That's equal to I square into R into T into 1 by 2. That is, write 1 by 2 in the front, 1 by 2 heat. Another question, resistance of the conductor remains R and the intensity of the current is halved and the time is remains T seconds. Then we want to find heat generated. H is equal to I square RT. Here I changes to half. Then we write half square R T, that is equal to I square by denominator 2 square, that's equal to 4 R into T. Then heat generated will be quarter, 1 by 4th time of original heat.
Then we want to do resistance of the conductor changes, not change R, intensity of the current I again, and the time for which current flows is 2T. Then heat generated will be 2I square RT, change in heat will be twice. If the resistance is same R and the intensity of the current I and the time for which current flows is half T by 2, then heat generated will be half I square RT, then the change in heat will be half times. Thanks for watching. Please like and subscribe.